language, because we need to know this for the test that we're going to have on Thursday. Why are we going to substitute in? Let's go back to the definition. You got to know this definition. What is a solution?
To see if it fits the solution.
Y'all, have we gone over our notes at all since we started this unit? You laugh? Is that no? I've never looked at my notes before. That's what the language we need to be thinking about and understanding. Does that point, do those values make the mathematical statement, in this case, an inequality true, right? So what you're thinking about, Lexi, with the same is the idea of equivalency, right? Notice, am I creating a second inequality here? No. So don't forget those properties of equality, the commutative property, the distribution property, all those things are to see if inequalities or equations are equivalent. And they look different, but they're the same. If I ever say solution, and also remember, two different inequalities can have the same solution, and that's when those two inequalities are equivalent, right? But here I'm just asking, is this point a solution? So 3 times 5 minus 4 times 2 is greater than 7. Did we all get to that point at least? Everybody just get up to there? Okay? Anybody not get up to there that we need to ask a question? All right, 15 minus 8 is greater than 7, right? And what is 15 minus 8? So is this where we were split? We got a 7 on both sides. For a solution, does that make the inequality true? No. So is that a solution? No. We need to be careful about that, right? Now, if it had been greater than or equal to, would 5, 2 been a solution? Yes, right? Because 7 is equal to 7, so 7 would be greater than or equal to. So does that make sense? Are we comfortable with that idea, that difference? Okay, so important distinction there. So Frank started the summer with $475 and spends roughly $50 per week on food and entertainment, but he wants at least $200 left at the end of the summer. Write a mathematical statement that represents the situation. All right, we got to talk about this. I only see, at this point, one of these that would be a correct mathematical statement. Does anyone see which one, or one that could be? Anyone see the one that it could be?
$475 minus 50x.
Okay, it's got to be a 475 minus 50x, or minus 50w. That's a great start for a lot of these. Why can it not be plus?
Yeah, that was mine.
You're taking away.
You're taking away, right? We're not adding on to the 475. He's taking that 50 away. Right here, does anyone know why it cannot be 475 times d? That's, say again? Repeated addition. Are we repeatedly adding that 475? No, he just has 475 at the beginning. This is potential, but the only one that I see up here, actually there's two. These two are close. Why those two? Why 475 minus 50w is less than or equal to 200, which is the same as this one, it just has x instead of w. Why is that one close? Or what's different about it, I guess, than the other that we see up here?
It's an inequality.
It's an inequality. Why, based on the language of this question, does it need to be an inequality? At least 200. I know we haven't done as much with inequalities, but that's a key detail that we got to pay attention to. He wants at least $200 left. Yes, you could set it equal to and solve it that way and approach it from that perspective, but the inequality would be at least. Is this at least 200? No. At least 200 would be 200 or more. So what do I need to do to correct this? flip the sign, or the mathematical way to say that is reverse the direction of the inequality, okay? So 475 minus 50W needs to be greater than or equal to 200. Most of us were getting the idea of 475 minus 50W. The reason why I say it could have been this one is, notice if you add 50W to both sides, and that had been an inequality, 200 plus 50W needs to be less than or equal to 475. That would be equivalent, right? Using those properties of inequality. So for whoever thought of the 200 plus 50x, if you make that the correct inequality, because notice he has to be less than or equal to 475 because that's how much money he has, that would have been correct as well. Do we understand better why it needs to be an inequality? You got to look for those kind of statements, and that's why I said a mathematical statement. I didn't want to give away that as an equation or inequality. Hopefully that helps us understand better. Johnny, don't fall asleep on me yet. We're in the first 17 minutes of class. All right. So Frank stated, oh yeah, the whole thing, that he wants at least $200 left at the end of the summer. How many weeks can he spend money like this, right? So I see 5 weeks, I see 5.5 weeks. So how would I determine this, right? So first off, I am going to use the inequality at this point. So what am I going to do to solve that inequality? Okay, subtract 475 on both sides. And this is why we want inequalities. It makes our job easy to recognize what to do next. All right, what do I need to do?
Divide by negative 50.
Divide by negative 50. Right, so notice we're using those inverses. Why do I need to divide by negative 50 on the right-hand side as well? Properties of inequality, right? Remember, I don't want to just change the inequality. I want to create those zeros and ones so I can get to just the W, but I want the inequality to tell me the same story, right? I want it to be equivalent, right? And so Gracie, this is the, not Gracie, Lexi, this is the idea of equivalency, right? It's going to have the same solution set, okay? When we're using those properties of inequality. So W is greater than or equal to, I believe that is 5.5. All right, is that correct? Yes.
We have to swap the equality sign?
Yes. Okay. So remember, you can memorize that rule of having to reverse the direction of the equality. So good catch on that. What could I have done to make my life easier all the way through here? Remember, I told y'all I wouldn't even solve this as an inequality. I'd solve it as an equation, right? I would make this an equation all the way through. And then what number has to be on my number line? 5.5, right? So 0, 1, 2, 3, 4, 5, 6. Should it be an open point or a closed point, do you think?
Open.
Why open? Why is it not equal to? Thought we said greater than or equal to here. So there's a few, I'll say this, there's a few different ways to argue this one, actually. You could say he's only taking $50 out at the beginning of the week. In that case, can he have 5.5 weeks? No, he could only have 5 weeks, right? You could also make the argument that he is just spending it all the way through the week, and so he can take money out up till 5.5 weeks in. And so it depends on how you argue it. This is why it's important to justify your answers. There's not just one right answer. It depends on how you're thinking about it, especially in a word problem. And so it depends, 5.5, and so I'm just going to keep going all the way to the left, right? Why would I go to the left and not to the right? I don't want to be greater than that 200, so remember, let's say I test a 3, 475 minus 50 times 3 would be 150. That needs to be greater than or equal to 200, and that gives me 325. Is that greater than or equal to 200? Yes? So that means 3 is a, say it louder, solution, right? It's making the inequality true. All right, everything good to go here? I can't go past 0, why not? Is that true? So again, it's important to think about the context. And again, it depends on how you argue it. I might put a close point there, open point, things like that. Any questions? Ready to move on? Do you understand inequalities a little bit better and how to graph the inequalities, things like that? How to write and solve them, hopefully. Don't forget, this is a chance for you to ask questions and think about it. All right, I got a lot of different answers in this case. So identify all values of x that make the equation absolute value of x minus 4 equal to 3. Almost everyone said 7. I had one lone person say 7 and 1. Would that person care to explain why they said that?
I put 7 and 1 because 1 minus 4 is negative 3, and if it's absolute value, it's positive 3.
Is that true? Absolute value of negative 3 is equal to 3? Yes. So is 1 also a solution? Yes. Does that make sense? Okay. So please remember, we talked about this at the very end of class on Friday, and I know that was several days ago, which is why I included it here. How many solutions do absolute value equations usually have? 2, right? Because we see the positive one right away, right? 7 minus 4, well, that's equal to 3. But we also want to remember that, hey, the absolute value, right? Because remember, what is an absolute value?
Distance from 0.
Distance from 0, right? The absolute value of a number is distance from 0. And so negative 3 and positive 3 are 3 units from 0. Right? We good with that idea? Any questions before we move on with today? All right, you should already have the absolute value paper that I handed out last Friday. Go ahead and get that out. That's where we're going to pick up. Okay. Let's get those lights on. So you can actually find your papers. Are we this bored by math already? Just even though it's a Tuesday, it's basically a Monday. What is it? Y'all seem dead. DJ's alive. I can tell he's alive. But KJ, you alive back there?
Yeah, I was reading this.
Okay. I was worried about Jaden earlier. Jelani's already fallen asleep on me. Did y'all get enough sleep this weekend? Jelani?
Yeah, work.
Yeah, work. How much do you work every week?
I'm awake.
Okay. You just had to put your head down for a second? Okay. I just want to make sure you're taking care of yourself. I've had a lot of students in the past who do work. And they were like, yeah, I work 5 days a week. And I'm like, when do you have time to be a student? When do you have time to be a human being? Right? I know you gotta make money. I had jobs in high school too, but you also have to make sure that you have time to both be a student and just a human all at the same time. Money doesn't mean much if you're not enjoying life. Something to think about. Okay? Alright, so let's start looking at our objectives. CD, can you read our first objective today?
So, absolute value in inequality.
Alright, we gotta be able to solve absolute value equations and inequalities. There won't be a ton of that on our test on Thursday, but there will be a little bit. We'll have some practice of that today and tomorrow. And we'll have a review that I'll give out at the end of class today. Second objective. Grayson, can you read that second objective for us? Okay, please understand, we're not just solving absolute value equations and inequalities. What is informing our approach to it? What's informing the way we approach solving absolute value equations and inequalities? It's literally part of the second objective. Come on, what is informing my strategy for solving? Understanding of an absolute value. Okay, here's what I mean by that. Why did DJ come up with 1 and 7 as solutions? He didn't just make it up. Say again, Lindsay. Did you already know how to do everything with absolute value? Or how to solve the equation? Okay. From what? from Friday. What did we talk about on Friday that told you it had to be two solutions? He did the negatives as well, right? It's not just like randomly making stuff up. It's understanding that what can I take the absolute value of and get 3? Well, I could take the absolute value of a, it's not a trick. What can we take the absolute value of to get 3? Negative 3 and positive 3. That's what I mean by using my understanding of absolute values to inform how I solve it, right? I know that an absolute value, I can take the absolute value of 2 different numbers to get a positive 3. Use that, right? It's not just blindly following procedures, it's understanding why we're doing what we do. So let's get into the first part of this. All right, so notice how, so go ahead and open the document. Did I already send it to you? I did not. Let me send you the document for this. All right, send to everybody. All right, so I just sent you the absolute value document. It says absolutely modified, because I heavily modified where I pulled this from to make it make more sense. But it's got some really good elements here. All right, so you can use the properties of equality to solve a linear absolute value equation. Notice absolute value of x plus 6 equals 10. Subtracting 6 from both sides, we're left with absolute value of x equals 4. So what are they getting on their own first? Are they just like automatically figuring out what absolute value of x is, or are they doing something first? When you say solving it, what do you mean? Okay, so why did they not, so notice over here, absolute value of x minus 1 equals 5. Right away, they tell us that x minus 1 could equal a positive 5, or it could equal a negative 5, right? Because the absolute value of negative 5 is 5. Why did they not add 1 first for this next page? Huh? It's not, but I mean, like, why did we not add 1 here, but we did subtract 6 here? Okay, say it over here, Jaden. It's inside the, what's that symbol called? Absolute value, right? It's inside the absolute value. Because, and this is where I say we need to use our understanding of absolute value to inform how we approach this. The absolute value can be either positive or negative. Is this inside the absolute value? No. So I need to get down to just the absolute value first. Does that make sense? We good with that idea, hopefully? Okay? You should, if I did this correctly, on the back side, right, there's some reflection questions. What I want you to go ahead and do, okay, explain what an absolute value is, and then look at 1.2 and 1.3 a little bit more. Try to work with your group to answer these questions, right, based on 1.2 and based on 1.3. And then after that, we're going to get some practice with absolute value equations before we move into absolute value inequalities. All right? So again, talk with your group, try to figure out how we might answer these with our understanding of what absolute value equations are. And when I say 1.2 and 1.3, I mean the pages on the calculator. So you can flip back and forth through those pages on the calculator to make sense of this.